Leetcode daily challenge, and let's get started. Okay, so today is a hard problem. Shortest path in a grid with obstacles elimination. So we are given a grid of size m cross n, and every cell is either 0 or 1. 0 means it's an empty cell, and 1 means there's an obstacle there. And I can move in all 4 directions, and then I got to find the minimum number of steps it would take for me to go from this 0 comma 0 till the last possible cell, which is m minus 1 comma n minus 1. I think they're using, so they're using a 0 based indexing here. That's weird because most of the times people, when explaining, they use 1 based indexing. Oh, and here's the interesting part. We can at most eliminate k obstacles. Okay, I think this is the trickiest part in this problem, because if this was not there, then this would just be a normal pathfinding minimum pathfinding algorithm. You could have used a DP there, and if it is not possible, we need to return -1. Okay, and coming to the constraints are pretty weak, so it is 40. So I think we are free to do whatever we want, unless we are doing something the exponential or factorial scale. Apart from that, we should be fine. We can do anything. We can do DP, BFS, DFS, anything like that. And yeah, so how would we solve this? So as we can go in all 4 directions, we can't use a traditional DP because in DP we got to start at a point and go in a direction such that we always have previous values, but this is not like that. So here, so we can go, I mean, if something was like this, like it was something like this, so if something was like this, maybe, so there might be a case in which we got to go down and then take U-turn and then go up. So it I don't think this can be solved using traditional DP, but I may be wrong. We can think of this as a graph problem, and then maybe we can do a BFS or a DFS starting from here in search of our last point. I think that is a good direction. And what would the states at each point? So it would be currently at which position I am, and how many obstacles have I already used, already have eliminated, and how many obstacles are remaining, and maybe number of steps that it took me to get here, so that I could use that at the end for my answer. I think that should work. Let's try. So let me have a queue, and then I'll put in a tuple which says I'm currently 0 comma 0, and I've taken 0 steps, and I have all the options remaining with me. And then let me have a visitor array so that I don't keep going to the same places. And this is a basic BFS template I'm doing. I'm currently getting I'm getting the current tuple x comma y comma steps comma remaining is equals to q dot pop left. And I got to see if I've already visited this. Else I'm going to add this. Once that is done, I need to go to all the 4 directions. So one thing I can do is I can just write all these combinations of x1. I mean, if this is x, then this is x comma y, this is x minus 1, y x minus 1, y minus 1, x plus 1, y plus 1. So we have 4 directions, and there's a small trick up my sleeve. Instead of writing all those, I can have some directions. Directions x is equals to, so only 4, right? Go, okay, 4 directions, so it can be 1 comma minus 1, and then directions of y could be minus 1 comma 1. I think this would, okay, but these would be the diagonals. We don't need them. Yeah, I think these are the directions. So 0 1 1 0 minus 1 0 and 0 minus 1, these would give us all 4 directions. So yeah, so for I in range 4, so new x, which I'll denote by an x, would be x plus directions x of I, and then new y would be y plus directions y of I. So now I've got my new directions. So nx and ny would be all 4 neighbors of this current cell x comma y. And then I have 2 options. Option 1 is, it is if it is not an obstacle, then life would be very easy. So if, what's the name of the matrix? Grid. Okay, if grid of nx and ny, it's not an obstacle, it is 0, in that case life is very easy. Can just add it. So it would be nx comma and add it to the queue, nx and y, and then steps would be number of current steps plus 1, and I won't be using any magical wands to remove those obstacles, so it would still be remaining. But the real trouble begins when it is not an obstacle. So if it is not an if it is an obstacle, sorry, if it is an obstacle, and if I have nothing left, if remaining is less than or equals to 0, if it is not equal to, if it is less than or equal to 0, in that case then nothing I can do. I can't go in that direction, so I'll just forget that. And if it is not, in that case I would use up one of my superpowers. So it would be q dot add and if I ever get to the last one, if x equals to length of grid minus 1 and y is equals to length of grid of 0 minus 1, in that case I'm already where I need to be. So I'll return steps. And these nx and ny, they might go out of bounds. So if nx is less than 0, or nx is greater than or equals to length of grid, or if y is less than 0, or if y is greater than or equals to length of grid, in that case I would oh, so if I click on continue in a nested loop, would this continue of this loop or the bigger loop? Check. I know I'm supposed to know this, but it's always good to I'll only skip the inner loop. So, right. Okay, good. Would this work? I don't know. Check. Return. If I didn't find this last cell till the end of my BFS, then it means there is no way I can do this. So in that case, I should return -1. Okay, append. Why can't Python? Why can't Python be consistent? Like for set it is add, and for queue and for list it is append. Why? Length of grid of 0. So it would make our lives a lot easier. Nevertheless, it's still a lot better than pushback. Okay. So I'm going out of bounds here. It should be ny. Okay. So then the second test case I'm getting a wrong answer. I'm getting an output, but I'm supposed to get in this case, right, in the else case, when there is an obstacle, in that case I use up one of my powers, right? Okay, the test cases have passed, but I don't know, it still looks a little fishy for me, especially this visited thing. It keeps bugging me, because there might be this situation. Oh, let me show. I don't know how to use. I just migrated to a Mac OS, and I found out that it doesn't have a paint. It doesn't have a default paint. This paint is from Windows. I'm using Parallels. So I don't know. I should research more on how to use paint on how to draw something on a MacBook. Cool. Okay, so I was saying, let's say if I'm here, and then this is where, let's say this is something. No, let's say this is the starting point, and this is I'm here somewhere. So maybe there might be two ways in which maybe I come here like this. Then there might be another way. I'm coming from right here. And maybe this way is shorter than this way. But if this has already been visited by this way, then maybe I can't visit it here. But that doesn't make sense, because if I've already visited this through this method, in that case it means that this is shorter than this, so it's not a problem. But what if now it makes sense. What if in this case, even though it is shorter, it has used up more superpowers of eliminating obstacles than this. Okay, and then maybe there is an obstacle here which has to be passed and there is no other way. So if I come through this way, in that case I would I won't go any further because I've already used up all my magical powers. So maybe even though this takes more steps to reach here, but it has conserved its magical powers. So I have to somehow allow this path. But in the current way, how I'm using a set and I'm storing x comma y in the coordination x comma y I'm using in it. In this case, the second way would get stopped because this has already been visited by this one. So this won't work. Yeah. So I got to add some extra information. Okay, so how do I deal with this? So I need to differentiate between this and this. I'll do one thing. I'll put all the things. I mean, even though both of them, even though the coordination is, even the coordinates are same, and let's say even the number of steps are same, something has to be different. Like if both are same, then in that case it doesn't matter if I allow this or not. So the only the only case in which I have to allow this is if it is somewhat different from this way. It might be in the number of steps or it might be number of magical parts remaining. So why don't I differentiate all of them? So instead of just adding x and y, I'll also add steps and remaining. And the space complex still remains the same because I'm just multiplying it with a scalar which is 2. uh, this and not this I think should work. I'm giving it a shot. Ah, something's happening, friends. I think I can see a TLE. Yeah. The 30th test case. Why is that? Okay. But I don't know. The only way I would get a TLE is if I'm going into some kind of infinite loop, because the code I've written it shouldn't TLE for this constraint. The time complexity of BFS would be number of word number of vertices plus number of edges. So in the worst case, I would just traverse each of them once. Okay. No, but e- let's say even if I'm taking into consideration these four, so x would be 40, y would be 40, so it would be let me consider this as 100, right? 10 square. So 10 square into 10 square to steps, it can be 10 square. It would be 10 power. It would be 10 square because I can take at most x steps in the right, y steps. Oh no, I can take more than that. I can take m into n steps if I go like a snake. So here it would be 10 power 4. So 10 power 4, 10 power 4, 10 power. Okay. So remaining can be 10 power 4. So 10 power 4, 10 power 4, and 10 power 4. It's not as fast as I thought. But in most of the cases, I won't reach all of them because in most of the cases, I would be out of remaining magical powers. Okay. Mm, I mean, 183 is a lot, so that is why. I think we don't need to put remaining in this visitor set because if the coordinates are same, if number of steps are same and visitor and remaining powers are same, in that case both of them are equivalent to me. So why should I allow this one? This would be double work for me. I don't know. Check. Another TLE. I don't think it worked. I don't think it worked. Wrong answer. Why? Okay, it's better than TLE. Okay, so so remaining is something it is important for visited. I don't understand why. If there are two paths with same xy, same steps, and same remaining, and why is it different? Steps important. I'm just brute forcing my way. It seems to work. It worked, but I'm not happy. I don't know why. I mean, I don't know. The hardest part of this problem is keeping track of visited. And somehow I was lucky it got accepted, but I still don't have a great, I still don't have a good explanation for why I've used x comma y coordinates and remaining magical powers, and why I haven't used steps. Let me think. So, so do I need steps? So let me try to prove what happened, and then we can think of how to approach this visited thing. So let me say, okay, let me assume that number of steps is not important. So if I have two paths, both of them leading to this x comma y, and then they have same steps, in that case, yeah, it might happen that they have the same steps, but they shouldn't have the same remaining. Okay. So why? How can they have the same number of steps? I mean, how can't how can't they have the same number of steps and same number of remainings? So the main question. Let me, if I frame the question. Oh no! I want to open notes. I don't want to open packets. I want to open notes. Yeah. So the question is, can I have two paths with same coordinates, same steps, and same, magical powers? I mean, same K. I thought the answer was no. But it seems the answer is yes. But if you have same coordinates, same steps, and same K, in that case they're equivalent, right? Okay, but it also. Okay, but I don't understand. So, so, so it means that these three are not the ultimate set states for my BFS. Maybe the path they have pinned might be different, and that might give us that might give us different results. So maybe that's this that is why we can't have two paths with all these four. So guys, this is it. And it's a little clumsy, and I've got two wrong submissions. But yeah. So bye. See you tomorrow.